I misspoke just a bit at the end of that last video. Technically speaking, we're talking about more general parallelograms here than rhombuses, but if we understand how a parallelogram works, then we understand a rhombus is just a slightly nicer variety of that. Anyway, with a parallelogram, what we have is a shape something like this, where it is very close to a rectangle, but it's slanted a little bit. So what we want to do there is think in terms of the height of an altitude, almost, which is a thing we'll talk about more when we get to our ideas with general triangles. But it's actually even easier to visualize what goes on here, because with a shape like that, what we can notice is that with the slant, that extra right triangle off on the side there can be almost cut off and folded over to the other side to just turn that into a rectangle. That we're only off by a little bit of an angle in order to be able to get a rectangle because of the way that, well, transversals work in terms of the angles there. So really, all we have to do here is that same base times height idea, length times width idea. It's just we have to be a little bit more careful about the height not being the height along the slant, but the straight up and down from the top to the bottom in a non-triangular, I guess you could say, region. Where, let's take one example here to see this in action. So for this, we want to find the area of the given parallelogram, or in this case, there's nothing to this at all. We just have to understand here that for this area, we are given that the height here is 4 centimeters based on that dotted altitude that we're given, and the base or width is 8 centimeters. So our total area is 32 square centimeters as we have it. And that's really all there is to basically any of our quadrilaterals, especially the nicer ones. There might be a little bit more we could do for other shapes, and we'll see what goes on with trapezoids later under a similar set of assumptions. But before we get to that, we probably want to get a better understanding of those little triangular parts. So we'll also take a minute here to talk about the areas of triangles, which follow this exact logic, just sliced in half.